Welcome to The Curious Machine. Today, we're embarking on a deep dive into a topic that's literally all around us, yet endlessly complex ourselves. We're talking about humans, Homo sapiens.
hmm
You might think you know what it means to be human, but our journey today will peel back the layers on our biology, our, well, surprising history, and our incredible societal complexities. We'll reveal some truly profound insights.
Yeah.
Our mission is to uncover what truly defines us, how we got here, and, what makes us so utterly unique on this planet.
It's really remarkable how much we take for granted about our own species, isn't it?
It really is.
We're going to explore not just the facts, but the fundamental reasons why we've become the dominant primate.
From our distinct physical traits right through to our incredibly intricate social structures.
Okay, so let's unpack this then. When we say human, what are we really talking about? Is it exclusively Homo sapiens, or is the definition maybe a bit broader?
Well, technically, human can refer to all members of the Homo genus. That includes quite a few extinct relatives.
But yes, you're right. In everyday conversation, it generally means Homo sapiens. It's interesting. Carl Linnaeus coined the term Homo sapiens, which means wise man or knowledgeable man.
Wise man, hopeful.
Yes. And what's particularly fascinating is that even among scientists, there's still, debate on whether extinct groups like Neanderthals should be considered a totally separate species or perhaps a subspecies of Homo sapiens.
So the lines are kind of blurry.
Exactly. It really highlights how nuanced evolution can be. It's not always clear-cut boxes.
And despite how special we sometimes think we are biologically speaking, animals, correct? Not some separate category we just invented.
Precisely. Yeah, it's a common misconception, maybe wishful thinking sometimes. But from a biological standpoint, humans are definitely animals.
Right.
We're the most common and widespread primate and actually the last surviving species of our genus, Homo.
The last one standing.
Indeed. We're characterized by our relative hairlessness, our obligate bipedalism, which just means we walk on two legs, all the time,
Yeah.
and our high intelligence.
And that intelligence ties into adaptability.
Absolutely. If we connect this to the bigger picture, our exceptionally large and complex brains are absolutely key. They're key to our incredible adaptability, allowing us to develop sophisticated tools, complex civilizations, and, thrive just about everywhere. Deserts, Arctic, you name it.
That adaptability is just amazing when you think about it. So speaking of evolution, how do we fit into that grand, sprawling story of life? Where did our particular story begin?
Humans are very much a part of the ape family. Our lineage split off from chimpanzees and bonobos somewhere around 8 to 4 million years ago.
That long ago, wow.
Yeah, it's deep time. And a truly pivotal genetic event happened during this divergence. It was the formation of human chromosome 2.
Chromosome 2, what happened there?
Well, it looks like it resulted from the fusion of two ancestral chromosomes. This left us with 23 pairs of chromosomes, whereas other apes have 24 pairs.
Huh. That sounds like a tiny genetic difference, almost like a typo. You said it had massive implications, though. What kind of implications?
Well, this seemingly minor genetic rearrangement is thought to have played a really pivotal role in shaping our unique brain development, our cognitive capacities. It's a key factor.
So it helped set us apart.
Yeah, exactly. It set our evolutionary path distinctly apart from other apes, really allowing for the development of our higher order thinking, maybe even consciousness as we know it.
Okay, and then our specific genus, Homo, when did that start to emerge?
It evolved from an earlier group called Australopithecus. The earliest actual record we have of Homo is a 2.8 million year old specimen from Ethiopia.
2.8 million years. Okay, so our family line really starts to take shape there. And then Homo erectus comes into play. I've heard that name.
Yes, Homo erectus. They evolved around 2 million years ago, and they were a real game changer.
How so?
They were the first archaic human species we know of to leave Africa and disperse across vast stretches of Eurasia. Huge deal.
Wow, the first travelers.
Exactly. And they also developed what we'd recognize as our characteristic human body plan. Longer legs for more efficient walking, a more upright posture, really optimizing that bipedalism.
Okay, so Homo erectus sets the stage. When did our specific species, Homo sapiens, the ones looking back from the mirror, make its grand appearance?
Homo sapiens emerged in Africa around 300,000 years ago, probably evolving from earlier species like Homo heidelbergensis.
This also in Africa?
Yes. Then, in at least two major migratory waves, we think roughly 130,000 to 100,000 years ago, and then again, maybe 70,000, 50,000 years ago, Homo sapiens started migrating out of Africa.
And spreading out.
Spreading out, yeah. As they spread across the globe, they gradually replaced, or in some cases even interbred with, local archaic human populations like Neanderthals and Denisovans.
Interbred, so we carry some of their genes.
It seems so. Genomic research has revealed that these archaic humans might have contributed up to, say, 6% of their genome to present-day non-sub-Saharan African human populations.
So we're kind of a mosaic then,
Yeah.
a hybrid species in our ancestry carrying these echoes. That's really fascinating.
It is, isn't it? It changes the picture from simple replacement to something more complex.
Absolutely. What were some of the other really significant physical changes that marked human evolution during this long journey?
Well, the most significant adaptations probably include our relative hairlessness, as we mentioned.
Right, the sweating thing.
Exactly. Our commitment to bipedalism, a really remarkable increase in brain size over time, and also a noticeable decrease in sexual dimorphism.
Sexual dimorphism, that's the difference between males and females.
Yes, the reduction in pronounced physical differences like overall body size or muscle mass compared to some of our primate relatives. Think of gorillas, where males are much larger than females. That difference is much less pronounced in humans.
Gotcha.
And the specific relationship between all these changes, why less hair, why bigger brains, why walk upright, the exact why and how they all connect is still a really dynamic subject of ongoing scientific debate.
Always more questions. So, okay, we've evolved physically, we've spread across the globe, adapted to different places. What happened next? How did we go from these maybe scattered small groups to the incredibly complex societies we live in today?
Well, for the vast majority of our history, up until about 12,000 years ago, humans were nomadic hunter-gatherers moving around, following the food.
The standard image of early humans.
Pretty much. But here's where it truly gets interesting. A massive shift. The Neolithic Revolution. It started around 13,000 years ago, particularly in Southwest Asia.
The agricultural revolution?
Exactly. It fundamentally changed everything. It saw the emergence of agriculture, farming, and permanent settlements. Our whole way of life shifted.
So, staying put, growing food.
Right. And this led to consistent food surpluses, which then allowed for the domestication of animals, and eventually the widespread use of metal tools for the first time. Huge changes.
And that's the point when what we'd call civilizations really started to take root then. Cities and things.
Precisely. We saw what's called an urban revolution in the 4th millennium BCE. City-states developed, particularly the Sumerian cities in Mesopotamia.
Right, Mesopotamia, cradle of civilization stuff.
That's the place. And this is where the earliest known writing, cuneiform, appeared around 3000 BCE. Think about that. Writing.
Game changer.
Totally. And other major civilizations like ancient Egypt, the Indus Valley civilization also rose around then, developing crucial technologies like wheels, plows, sails, and starting complex trade networks.
It sounds like this constant cycle of innovation, then expansion, but sometimes decline too.
It absolutely was. There's evidence, for instance, of significant periods of drought, maybe contributing to the decline of some of those very early civilizations. But then new ones would emerge. You had the Babylonians, the Poverty Point culture over the Americas, the Minoans in the Mediterranean, the Shang dynasty in China.
So constant ebb and flow.
Yeah. Then we entered classical antiquity, think ancient Greece and Rome, and later the Middle Ages, marked by the huge influence of Christianity in Europe, and the Islamic Golden Age in the Middle East, which saw incredible advancements in science, math, architecture.
Okay, fast forward quite a bit to the modern era. Things seem to just explode then, don't they, in terms of global reach and technology?
Absolutely. The early modern period, starting a few centuries ago, saw the Renaissance in Europe, the Age of Discovery.
Columbus and all that.
Right, which led to the colonization of the Americas, the massive Columbian exchange of goods, plants, animals, diseases, but also, tragically, the Atlantic slave trade and devastating indigenous genocide.
Darker chapters.
Definitely. But this period also marked the scientific revolution. Huge breakthroughs in math, astronomy, physiology, really laying the groundwork for what came next.
In the last couple of centuries, it just feels like an incredibly accelerated pace of transformation.
It certainly has been. The late modern period brought the technological and industrial revolutions. Innovations like imaging technology, completely new transport systems, massive energy development. It fundamentally changed daily life for millions.
Hard to imagine life without it now.
Isn't it? And the 20th century, despite 2 devastating world wars, also gave us electricity grids, penicillin, semiconductors.
The basis for computers.
Exactly. The internet, computers. The world is now increasingly globalized, interconnected, all driven by this information age. It really makes you wonder what incredible shifts are just around the corner for us.
It does. As we think about how far we've come culturally, maybe let's circle back to the biology, the machine that made it all possible. What truly sets our bodies apart, biologically, even from our closest ape relatives.
Yeah, it's striking. While most of our basic physiology is homologous to other animals, meaning we share a lot of basic structures.
Same basic toolkit.
Right. We do have some really distinct features. Take our teeth, for example. Our dental formula includes proportionally shorter palates and much smaller teeth than other primates,
Smaller teeth. Why is that?
potentially linked to changes in diet, especially with cooking food, which makes it softer. And we're also gradually losing our third molar's wisdom teeth. Some people never even develop them now.
Huh. Evolution in action. And what about our hair? Or, the lack of it compared to other apes. That's pretty noticeable.
It is, you're right. Well, we technically have a similar density of hair follicles.
Really?
Yeah, similar number per square inch as, say, a chimp. But most of ours is predominantly vellus hair, that really fine, almost invisible body hair, not thick fur.
So why lose the fur coat?
The leading theory ties back to what we discussed earlier, adaptability, especially keeping cool. We compensate for the lack of fur with about 2 million sweat glands spread over our entire bodies, far more than chimps have.
Ah, the sweating again.
Exactly. This allows us to be among the best long-distance runners in the animal kingdom. It helps us avoid overheating, especially in hot climates. Think about persistence hunting, literally running prey down over miles and miles. Our sweating ability is key.
That's an incredible adaptation. A real superpower derived from, sweating.
Pretty much.
Okay, what about our genetics? How similar are we to each other, really, as Homo sapiens? Are the differences we see mostly superficial?
That's a great question. Any two humans chosen at random are, on average, 99.5% to 99.9% genetically similar.
99.9%, that's incredibly similar.
It is. It makes us remarkably more homogeneous genetically than other great apes like chimpanzees. There's more genetic diversity within a single group of chimps than in the entire human population.
Wow, why so similar?
Well, this small variation strongly suggests something called a population bottleneck occurred, probably around 100,000 years ago. Our numbers might have crashed, reduced to a relatively small group of breeding pairs.
So we all descend from that small group.
That's the prevailing theory, yes. It means we're all incredibly closely related, relatively speaking.
Fascinating. And our life cycle? Birth, growth, aging. What makes human life stages distinctive compared to other species?
Several things stand out. Compared to most other species, human childbirth is notably dangerous.
Because of our big heads.
Essentially, yes.
Yeah.
The fetus's large head size relative to the mother's pelvis makes for longer, often more painful and risky labor than in other primates. What's also quite unique is that typically both parents provide extensive care for human offspring. That's a stark contrast to most other primates, where care is primarily, almost solely, maternal.
Shared parenting, that's big.
Huge social implications. We also have that unusually rapid growth spurt during adolescence, that awkward teenage phase.
Don't remind me.
And uniquely among primates, human females undergo menopause around age 50. They stop being able to reproduce.
Why would that evolve? Seems counterintuitive.
Well, there's the grandmother hypothesis. It suggests that menopause might actually increase overall reproductive success for the family unit.
How?
By allowing older women to stop bearing children themselves and instead invest their time and resources in helping their existing offspring and grandchildren survive and thrive. It fosters multi-generational learning, communal childcare, foundational stuff for human society.
The supportive grandma role is actually an evolutionary advantage. That's lovely.
It's a compelling idea, yeah.
And our diet, you mentioned cooking earlier. We're omnivores, but how flexible are we?
Humans are incredibly flexible omnivores. We can consume a huge variety of plant and animal material. You see human groups throughout history adapting diets from purely vegan to primarily carnivorous, just based on what's available.
Adapting to the local menu.
Exactly. And fire, as you said, used for cooking since Homo erectus times, drastically changed the nutritional value and digestibility of our food, made more calories available.
And agriculture changed things again.
Big time. It led to new dietary adaptations, like the evolution of lactose digestion persistence in some adult populations, allowing them to consume milk and dairy products long after infancy.
So we're still adapting.
Constantly. It makes you wonder, doesn't it? How much has our diet shaped our biology over millions of years, and how does our biology now influence what we choose to eat, grow, and produce today?
Definitely food for thought. Okay, let's shift focus slightly, maybe inwards, to what many consider our truly defining feature, the human mind. What makes our brains so uniquely special?
Well, the brain is the command center, isn't it?
Yeah.
The focal point of the central nervous system. It controls everything from involuntary stuff like breathing to higher order functions like abstract thought and reasoning.
And the prefrontal cortex is key.
Very key. We possess a larger and significantly more developed prefrontal cortex than other primates. That's the region right at the front, associated with higher cognition, complex planning, decision-making, navigating intricate social behavior, self-awareness, all the really complex stuff.
So does that definitively mean we're the most intelligent species on Earth? Is it that simple?
Well, objectively defining and comparing intelligence across species is actually really difficult. Other animals excel in ways humans absolutely do not. Think of a bat's echolocation or a bird's navigation.
Good point. Different kinds of smarts.
Exactly. However, we do possess some truly unique cognitive traits. For instance, humans might be the only animals with true episodic memory,
Episodic memory.
the ability for mental time travel. We can consciously remember specific past events in vivid detail, reliving them almost, and we can mentally project ourselves into the future, imagining different scenarios.
Wow. That's powerful.
Incredibly powerful. We also have an unusually high degree of flexibility in our facial expressions, allowing for incredibly nuanced emotional communication. And maybe oddly, we seem to be the only animals known to cry actual emotional tears.
Huh. Never thought about that. What about something really universal like sleep and dreams? Anything uniquely human there?
Well, many animals sleep, of course, but human sleep needs vary quite a bit by age. And we know chronic sleep deprivation has really negative health effects for us.
Tell me about it.
Yeah. During sleep, we dream experiencing those vivid sensory images, sounds, stories. Dreaming is primarily stimulated by a part of the brainstem called the pons, mostly during REM sleep, rapid eye movement sleep.
And dreams can be useful.
Sometimes. They can even spark creative thoughts, inspiration. People report solving problems or having artistic breakthroughs seemingly from dreams.
Okay, but what about consciousness itself? That feeling of being here, aware, still a huge mystery.
Yes, one of the biggest. Despite centuries of philosophy and science wrestling with it, the true nature of human consciousness is still, well, poorly understood. It's often called at once the most familiar and most mysterious aspect of our lives.
Familiar because we live it, mysterious because we can't quite pin it down.
Precisely. The only thing everyone really agrees on is that it undeniably exists. We experience it, but what it is, how it arises from the physical brain, huge questions remain. What exactly is this awareness of our internal world and the external world around us?
Deep stuff. How do our emotions and motivations fit into this complex picture? They drive so much of our behavior.
They absolutely do. Human motivation is incredibly complex. There are theories like Maslow's hierarchy of needs.
Basic needs first, then higher goals.
Right, that general idea. Describing the process of satisfying needs from basic survival up to things like self-actualization, belonging. Emotions, meanwhile, are these biological states tied to our nervous system. They profoundly influence our behavior, our decisions, our ability to learn from experience.
And they can be disruptive, too.
Certainly. Acting on extreme or uncontrolled emotions can lead to social disorder, definitely. Some studies even suggest that individuals involved in criminal behavior might, on average, have lower emotional intelligence. But emotions are also crucial for connection, empathy, making good judgments.
So it's balance. What about happiness?
Happiness is a really complex emotional condition. It's not just about feeling good all the time. Recent research even suggests that true, deep happiness might actually involve experiencing negative emotions when they're appropriate or warranted. They can provide meaning, contrast, depth to our lives.
Interesting. Experiencing sadness helps you appreciate joy more.
Something like that, perhaps. Or provides important signals about our lives.
Okay, moving beyond the individual mind then, let's talk about the incredible tapestry of human culture and society. What truly sets us apart in how we interact and organize ourselves on this massive global scale?
Well, our unprecedented intellectual skills were clearly a primary factor in our technological advancement, and ultimately our domination of the biosphere.
What specific skills?
We seem to be the only animals known to actively teach generalizable information lessons that can be applied broadly, not just copied in one specific situation.
Teaching concepts, not just actions.
Exactly. We also use something called recursive embedding to create complex concepts. Think of it like nesting ideas within ideas or clauses within sentences to build really intricate thoughts.
Like mental building blocks.
Yeah. We also engage in folk physics for tool design, sort of an intuitive, practical understanding of how the physical world works, like gravity, leverage, momentum, without needing formal physics training. And back to cooking. We're the only animals known to consistently cook food in the wild using controlled fire. That's a foundational cultural practice.
And language, of course, it seems absolutely fundamental to everything we do collectively.
Language is indeed unique to humans. It's a definitive feature and a cultural universal found in every single human society we've ever encountered.
And it's different from animal communication.
Very different. Unlike the limited communication systems of other animals, human language is fundamentally open.
Open, meaning
Meaning, essentially infinite number of meanings can be produced by combining a finite number of symbols, sounds, or letters. We can always create new sentences, new ideas.
limitless combinations.
Right. And it also allows for displacement. We can talk about things that aren't happening right here, right now. We can discuss the past, plan for the future, talk about abstract concepts, hypotheticals.
Things that don't even exist.
Exactly. This capacity for shared, complex narratives, storytelling. It has profoundly shaped our collective history, our cultures, our ability to cooperate.
What about the arts? Music, painting, stories, are they unique to us?
The arts are certainly a defining characteristic of our species. Visual arts, literature, performing arts, music, they're everywhere. And what's truly fascinating here is the timeline. The earliest potential evidence of art we've found dates back maybe 300,000 years.
Before Homo sapiens?
Potentially, yes. Shell engravings attributed to Homo erectus, long before modern humans even evolved.
Wow, so art is older than us.
The impulse towards symbolic expression might be, it suggests the development of imagination through art, combined perhaps with logical reasoning, may have given early humans a significant evolutionary advantage, maybe in problem solving, social bonding, transmitting culture across generations.
Art as an evolutionary tool, that's a cool idea.
It is.
Now, with all this capability, tools, language, cooperation, art, we've also had an immense and often, let's face it, transformative impact on our environment. What does that look like on a global scale today?
The scale of our impact is, well, it's staggering. Consider this. Humans and our domesticated animals, cattle, pigs, sheep, etc., now represent an incredible 96% of all mammalian biomass on Earth.
96%. So wild mammals.
All wild mammals combined, elephants, tigers, whales, mice, everything make up only the remaining 4%.
That's sobering.
It is. And our population has just exploded. It took over 2 million years of human prehistory for our global population to reach 1 billion people. But it only took about 207 years to grow from 1 billion to 7 billion.
And we're over 8 billion now.
Past 8 billion in November 2022. This incredibly rapid growth, coupled with industrialization and often unsustainable levels of consumption, has unfortunately led to widespread environmental destruction, pollution, climate change, habitat loss. It's a significant contributor to the ongoing mass extinction event that scientists say we're currently in, losing biodiversity at an alarming rate.
Yet at the same time, our expansion continues outwards. We've explored Antarctica, the deepest parts of the ocean, even outer space. We've had a continuous human presence on the International Space Station since the year 2000.
That's right, pushing boundaries constantly.
So considering this immense impact we have, both positive and negative, and our relentless curiosity that drives us to explore everything from the deep sea to deep space, what does all this mean for our future? Where are we heading?
Well, if we try to connect all these threads, this deep dive into what it means to be human, it really reveals a species that's not only incredibly complex, adaptable, innovative, but also profoundly impactful. For better and for worse, we shape our planet, and now maybe even beyond.
Yeah. We've traced this incredible journey, haven't we? From bipedal apes figuring things out on the savanna to architects of global civilizations driven by this unique blend of biology, psychology, and culture. We seem absolutely wired for curiosity, for connection, and for constant change, always pushing the boundaries.
We are, which I think prompts a really fundamental question for you, for everyone listening. Given this incredible, complicated story of our past and the immense challenges, but also the opportunities of our present, what kind of human future will we collectively choose to build? Thank you very much for sharing this enjoyable conversation with us. Until we meet again tomorrow with a brand new topic, take very good care of yourselves. Goodbye.